welcome. Closed set on matrix space. In first lecture, we have seen that what is meant by closed set and that limit point of E and closure of E. These concepts. When we say that X is the limit point of E, when we say that sequence Xn converges to X, and closure means that type of set of all limit points. It is nothing but the closure of E and it is denoted by E bar. Here we are going to discuss next article, next theorem you may say of closed set. These are the two theorems, one theorem and second theorem. Simple theorems. If E is any subset of matrix space M, then E bar is closed. If E is any subset of matrix space, then E bar is closed. That is, E bar is closed in symbolically, we write E bar is equal to E double bar. Because when we say that E is closed, it means that E is equal to E bar. Here we say that E bar is closed, therefore we write E bar is equal to E double bar. When E is closed, then always E is subset of E bar. Here always E bar is subset of E double bar, isn't it? Because E bar is closed. Therefore, E bar is a subset of E double bar. That is only to prove that E bar contains E double bar. By using these two, we can prove this. One is we know always, and only we want to prove this. That is, if we take member of E double bar, prove that that member belongs to E bar. Therefore, take X belongs to E double bar, and to show that X belongs to E bar. To show that any open ball B of XR contains point of E. This is the meaning of X belongs to E bar. What is X belongs to E bar? X is the limit point on this set E. Therefore, to show that any open ball B of XR contains point of E. This is the meaning of this. Means we want to show as X belongs to E double bar, what we say that when X belongs to E double bar, then B of XR contains point Y say belongs to E bar. This is the meaning of X belongs to E double bar. What is that? Open ball of radius R about X contains point Y belongs to E bar. Let S is equal to say rho of x1, this is the distance. Choose T number such that positive number which is T less than R minus S. This is our arrangement for our convenience. S is number, T is positive number, and here is the construction. R is the radius for this open ball and R minus S is greater than this T. Now here Y belongs to E bar. Y belongs to E bar. Then similarly here we say X belongs to E double bar. Then B of XR contains point Y belongs to E bar. Now what is Y belongs to E bar? What is the meaning? B of YT you may say contains point say Z belongs to E. Means this sentence and this sentence, they have same structure. X belongs to E double bar, then we say that B of XR contains point Y belongs to E bar. Y belongs to E bar, then we say that B of YT contains point Z belongs to E. Now rho of XY is equal to S and rho of YZ is less than T, but T is less than R minus S, hence we write this much. By triangle inequality, rho of xz less than or equal to rho of xy plus rho of yz. What is rho of xy? It is less than s is equal to s, and rho of yz is less than r minus s. S cancel. We take rho of xz is less than r. Then what is the meaning of this? Z is the member of open ball of xr. Z is the member of open ball of B of xr. Therefore, B of xr contains a point Z which belongs to E. That is, here we say that what we want to prove, x any open ball contains point of E. Any open ball contains point of E, and hence proof. Hence proof. This is the first theorem. One note is here. Similarly, as a for open set, in any matrix space M row, the sets M and phi means total and empty set are both closed sets. Phi is always and here is also. Here second property, second theorem is about union. If F1 and F2 are closed subsets of matrix space M, then F1 union F2 is also closed. Here we want to prove F1 union F2 is also closed. What it means? It means F1 union F2 is equal to F1 union F2 bar. This we want to prove. Let x belongs to F1 union F2 bar. Why? Because here F1 union F2 is equal to F1 union F2 bar. This is our target to prove this result. F1 union F2 is closed. It means this. And always we know that always F1 union F2 is subset of F1 union F2 bar. Because here what we say, E bar is subset of E double bar, or E is closed subset, then E is subset of E bar. Similarly, here F1 union F2 is subset of F union F2 bar. Only to prove that, what only to prove that F1 union F2 bar is a subset of F1 union F2. Therefore, take member belongs to this F1 union F2 bar. Hence, we take x belongs to F1 union F2 bar. Let this equation number 1 and prove that that member belongs to F union F2. What is the meaning? Meaning, x is the limit point. Therefore, that sequence converges to x. This is the meaning of this closure. Then there is a sequence xn of points in F1 and F2 converging to x. This is the meaning of that. When we say that x belongs to E bar, then what is that? Then there is a sequence xn of points of E converges to x. Here, there is a sequence xn of points in F1 and F2 converging to x. Apply this definition of closed. But xn have subsequence consisting of points in F1. xn मध्ये कुठले sequence आहे of points in F1, or because here is the union, or subsequence consisting points in F2. That is the meaning of that union F1 and F2. xn have subsequence consisting points in F1, or that type of subsequence consisting points in F2. Therefore, as any subsequence of xn must converge to x. That sequence must converge to x because x belongs to F1 and F2 bar, and that converging to x. It means either x belongs to F1 bar, which is F1, because F1 is closed. We are given F1 is closed. F1 is closed means F1 is equal to F1 bar. Similarly, x belongs to F2 bar, F2 bar is equal to F2 because F2 is closed, means F2 is equal to F2 bar. Therefore, x is equal to F1, means x is the member of F1 or x is the member of F2. That is, x is the member of either F1 or F2. Hence, we write x belongs to F1 and F2. This is the equation number 2. This is equation number 1. And from 1 and 2, we write which we want to wish. F1 and F2 bar is subset of F1 and F2. As always, this is always, therefore, as like this, A is subset of B, B is subset of A, then A is equal to B. Similarly here, F1 and F2 is equal to F1 and F2 bar. That is, F1 and F2 is closed. That is the theorem. Two notes are there. What are the notes? Intersection of any number of closed set is closed. Intersection of any number of closed, because intersection is common. Therefore, any number of closed set is closed. And union of infinite number of closed sets need not be closed. Here, important thing is that union of infinite number of closed sets need not be closed. These are the two statements which are helpful for our multiple choice questions. This is the closed sets on matrix space and the two properties, theorem you may say. Let us see on next part some again characterizations of closed sets on matrix space. Thank you.